Dr. Erica with Rosie Research, and we are going through the activities that we find in our imaging unit. And this is an awesome unit. I'm so excited to be releasing it. It's on Teachers Pay Teachers if you want to download it for your classroom. And the links are below for you. And so we're looking at how we count in binary. So you have a lesson plan that sort of gives you the basics of counting in binary and what they'll learn while they do it. And one of the activities, they can cut out these what we call binary cards. And you'll notice on the cards that the first card has 1, and then we double it to 2, we double it to 4, we double it to 8. And so one of the questions you can ask your students after they go through this sheet of counting in binary is, why do we want to double it? Or what would the next card be? Now we have this printout where they can cut out the cards. If you're going to be using this a lot in your classroom, you could use a piece in our supplemental materials that has these cards and cut them out and laminate them, which would be great. But what they're going to try to do is make all of the digits from 1 to 15 by coloring in the dots that they use on each card. So the idea is you have to use all of the dots on the card. You can't just use part of the dots. And so the card is either totally showing or not showing at all. And then you'll choose. So for 1, we're just going to use this guy, just a single 1 dot. So you would color that one in. For 2, again, you'd probably just use the 2 dots because you can't use 2 1s. And then for 3, you could imagine adding the 2 plus the 1 is 3. So I'd have these 2 on here. And as we go through this, you'll notice that the highest number we can make with this set of cards is 15, which is 8 plus 4 plus 2 plus 1. And you can ask the students, if we wanted to go higher than 15, what would we need to do? And we can't repeat any of these cards because a computer then won't be able to decipher between the two things, right? Everything needs to be unique. And these cards are unique in the place they hold, like either being right here or 1 over from there or 1 over or another over. So the placement of these, just like 10 is different from 100, which is different from 1,000, the placement of that 0 is really important in binary. So if we tried to add another 2 card over here, the computer would be utterly confused. Not to mention the fact that if we added just a 2 card over here, now the biggest number we would be able to make is 17. Whereas if we followed the same pattern from 1, 2, 4, 8, 16, now we can get all the way to 31 by doing that. And you can have the kids sort of try to figure out, what number could I count up to if I used 8 of these cards? If I had 8 cards going up, what's the highest number I could get? And these cards are each a bit of information, and then when you string 8 of them together, that's called a byte of information. And a lot of the information that we use in computers is in bytes. So this is a fun activity where they'll be coloring in the dots and whatnot. And then there's of course a key. We have keys for everything. But this key, just to give you an idea, it shows you exactly how you're going to make all of those numbers. It's all colored in nice for you. And similar keys are available for everything. And of course, as they go and they're more interested, they're going to want to learn, how do I write these digits in binary instead of having to use these cards all the time? And the idea is that, let's say I have just the 8 card showing, and then not the 4, the 2, or the 1. Well, I would say that the 8 card is on, so that gets a 1, and the 4 card is off, which is a 0. The 2 card is off, which is 0, and the 1 card is off, which is 0. So I could write 8 as 1, 0, 0, 0. And in fact, that would be 8 plus 0 plus 0 plus 0, so my digit there is 8. And so this worksheet sort of walks them through, how would you do it? So if I had 0, 1, 0, 0, that means I'm off for my 8 dots, on for my 4, off for my 2, and on for my 1. And now they can count up the dots. So there's 4 here, 1 here. Add that all together, that gives you your digit. And so there's a bunch of different worksheets that kind of approaches this from different angles. And it sort of brings them to the point where they will be writing. Here, all of the binary pretty much is filled in for them. But there will be a point where it says, how can you get this digit? What numbers would you add in, and what binary code would you have? And then you can also have them, we have some, of course, fun decoder activities with this. So here they're looking at the binary 1000, which we learned earlier was 8. And they can take that 8 and look on our chart, and that's an H. So they'll put a letter H here. This one is 1100. So the digit it is, they can add up the 8 dots plus the 4 dots, so that will be 12. And if I look on my chart, I'll get a L there. And in fact, when we go through this, it'll spell hello. It'll be the letters we need for hello, and they can unscramble that. So this is a great way to sort of bring that stuff in. We're going to be having some more of these worksheets coming out where they can decode things. It's a great way to get a feel for how does binary work? How do we represent letters and numbers and images all in computers, which only have lots of these little tiny magnets that are either spin up or spin down. So that is the gist of this activity that's in our imaging unit. You can download it on Teachers Pay Teachers. The links are down below. We would love to have you follow us there and see everything we come out with. But make sure to follow us also on Instagram to see what we are doing today.